morning, everyone. Welcome to the second edition of the one6G Summit. My name is Monique Calisti. I'm the CEO of Martel Innovate, and today it's a pleasure for me to guide you throughout a very rich and dense agenda that we will discover together. I'm very excited. Today we have we've received more than 600 registrations for this event. We have top speakers, excellent speakers from policy, from industry, from academia. And with them, we will discover the challenges and opportunities to pave the way towards intelligent and sustainable global 6G. We will cover several topics. As you know, we have many experts that will be giving presentations. We will have also some more interactive sessions. Please drop your questions in the chat and we will try to keep up with them. We will cover several topics, so there will be the chance for different kind of audiences to interact with us and to drop their questions. But before we start with the agenda, let me remind you about a couple of housekeeping rules. So I will share briefly my screen. I hope you can see it. So first of all, I would like to remind everyone that the sessions will be recorded and published on the one6G site. So if you don't have time to stay with us the whole day, you know that you can catch up. You can post questions and comments, as I said. Try also to animate and help us animating a little bit the community and the communication all across the one6G channels by using the hashtag of the event, that is one6G Summit 2022, and maybe tagging the one6G Global channel. Now, if you have technical issues, it might be, please contact the host on the chat and send us an email or send us an email at info@one6g.org. Now, having said that, it is my pleasure now to give the floor to Professor Nancy Alonistioti, that is actually the chair of the one6G, and that will give us a brief introduction. Nancy, the floor is yours. Thanks a lot.
Thank you, Monique. Thank you for the introduction. I would like to welcome everybody in this one6G Summit 2022. We are happy to have all these speakers today with us. one6G is a platform for open collaboration and open exchange of innovation and research ideas and work. one6G actually fosters the tight integration of one6G research and innovation with the vertical domain industries and the vertical domain sectors. And this is why we engage so many vertical domain partners and members in one6G. We look forward actually to receive more of the vertical domain partners and members since they have to contribute to the shaping of the new systems, the new emerging systems for 6G. We are now in the pleasant position to announce also the signature with the MOU signature with WWRF, another big association. Together with WWRF, we envisage new opportunities for synergies and for collaboration in a worldwide level in order to address the new challenges for 6G globally. And actually, we would like to play a key role to promoting 6G research, European 6G research worldwide as well. I would like now to address our speakers. I would like to thank them for their participation in this event, and I look forward to some interesting presentations and some interesting discussions during the summit today. I will be able to present in more detail the activities of one6G later on in a special session. So I invite everybody to be able to follow up on what we are doing in 16G. Although we are a new, let's say, association, I think we have many contributions and many activities to present. So I think now I would like to give the floor to our first speaker, Monique. So I think you take the lead now to introduce the speaker.
Yes, thank you, Nancy. And now it's my pleasure to announce our first speaker, that is Pavlos. Now I will have to go slow with the name, Fournogerakis. Pavlos is actually a project officer, program officer in the Smart Networks and Services Joint Undertaking at the European Commission. Pavlos, the floor is yours.
Thank you, Monique. Thank you, Nancy. I hope you can hear me and you can see me well.
Perfectly.
So apologies for the second Greek name in a row. I know it is difficult for you. But yeah, did not like it, not be so lucky so far. I would like to start by saying a few words about our organization. As Monique told you, I'm a program officer in this new Smart Networks and Services Joint Undertaking. Let me also share my slides so that you can. Okay, let me. So can you see the slides?
Yes, we can.
Let me.
We can also see a beautiful picture of the sea. Ah, no. Voila, full screen for your slides. Perfect.
Perfect, perfect. So many thanks again for inviting me in this annual 16G summit. And many thanks for giving me the opportunity to speak about the 6G research and innovation in Europe and our SNS activities in this regard. Before going into the substance of my presentation, I would like to introduce you or remind you of our new organization, the role of the new organization and its objectives. So let me, yeah, it works, perfect. Let me, sorry, I don't know if you see some black spots on the screen. I will try to hide them. So, SNS Smart Networks and Services Joint Undertaking was established as a legal and funding entity, one of the European partnerships to step up the green and digital transition. So this partnership is jointly led by the European Commission and by the 6G Smart Networks and Services Industry Association, which is the private part in this partnership. So we have many strategic and specific objectives, as you can see here in the left part of the slide, that are clearly stated in the Single Basic Act that led to our establishment. So you can see that the SNS, for example, targets reinforced European leadership in the field of next generation networks and services, connected devices and services, as we say, not only networks like in the past, to accelerate the digitalization of the European industry, economy, and society. The main aim is to position Europe as a lead market in this area, to positively impact the citizen, of course, citizens' quality of life, and support all these key sustainable development goals, boosting European data economy and ensuring European sovereignty in all these critical supply chains. The SNSDU has an ambitious mission with an EU budget of 900 million euros for the period 21 to 27, and the private sector will contribute with at least equal resources to the SNSDU activities. Two main missions, as you can see. One is to foster European technology sovereignty in 6G, by implementing the RNI program, leading to standardization starting around 2025 and towards industrial leadership in Europe by 2030, in line with all our policy objectives. The second big objective is to boost the 5G deployment in Europe. And to this end, SNS-JU coordinates with other programs like the Connecting Europe facility, and in particular the 5G corridor. Now, taking into consideration all these SNS program drivers, if you can also see in this list, SNS will support early research and innovation on enabling technologies like native AI, advanced RAN, cloudification, and so on and so forth. With, let's say, a goal towards to create new services, new smart services, beyond the current technological capabilities, such as the Internet of Senses, metaverse, holographic communications, and some examples that you see here in my slide. In terms of expected results, further to the new KPIs that we say, it is important to emphasize on the societal aspects. So we have the key value indicators now here, such as safety, security, trustworthiness, inclusiveness, and sustainability, which form the basis for the new research and design of 6G networks. International collaboration is also an important success factor because SNS is promoting a European approach towards 6G, but at the same time, trying to facilitate international cooperation and place Europe on par with other regions that have already started some 6G initiatives. Also, the SNS program offers opportunities to European stakeholders to achieve a leading position in the standardization process. And this is very important. You will hear also afterwards by the other speakers. Because we need to secure a leading position for Europe in the global ICT market over the coming 8 to 10 years, and participation in standardization activities is very critical. SNS also considers a broader value chain. It brings new actors beyond the verticals, as you can see also in the slide. So, for example, IoT and cloud IoT domains, and these are to be complemented by new players, such as the microelectronics industry, in view of the the potential impact at the standardization level. Now, SNS put also in place some mechanisms for collaboration with other partnerships, notably in the area of HPC or microelectronics or photonics. So again, this is also an important factor of success for our scope and our objectives. Going to the 6G vision and the status, I would like to say that before starting going into the details, that the 6G vision and the priorities are impacted by some important changes since the early days of 5G research and innovation. Of course, we have geopolitics on one hand. We know that, for example, all this coordinated approach on 5G cybersecurity that started in 2019. We know that the strategic importance of connectivity platforms and as a critical infrastructure is acknowledged. And the situation is even amplified by the COVID pandemic. As we know, a big part of economic activity was shifted online. And of course, COVID has exacerbated all the supply chain issues, but also the war in Ukraine. This is the latest war in Ukraine, pushed further towards the European strategic autonomy and critical infrastructure. So there is a reinforced need to address a complete supply chain, including also microelectronics. And this is also the rationale behind the CHIPS, the recently adopted CHIPS Act. In terms of industrial requirements, we have some changes. So because we have now a lot of new players in the wake of open networking approaches like hyperscalers, for example. And Europe needs to consolidate, and that's why we say that Europe needs to consolidate its leadership in clouds and supply capabilities as well as the previous, let's say, 5G capabilities. In terms of users, we all know the rising importance of verticals. It is also mentioned here. It is one of the main objectives of one6G association to bring more verticals in the game. So we need to include, to involve and engage the verticals from the onset, in the beginning. So this didn't happen in 5G, but now in 6G we need to have this strong requirement. So while 6G, a lot of 6G R&I programs have been launched in many regions of the world, as you can see here, US, China, Japan, Korea, there is still no unified 6G vision nor any declared commercial deployment initiative, of course, it's too early. We know that ITU is working currently on a unified 6G vision that should be available in 2023. There is, of course, a compendium of technologies and plenty of visions from industry, from other organizations like one6G, for example, with several important publications like the recent technology overview. But there is no unified vision, no unified version yet. 5GPPP also worked jointly towards a vision document that was published in June 2021. I'm sure you have seen this figure on the right about the convergence of physical, human, and digital worlds in 6G that will require support for digital twinning, immersive communications, cognition, and connected intelligence. Our targets, based on this, given this, let's say, background, it is that first of all we will have new capabilities for verticals and new application domains. We will have, for example, we have holographic communications or massive twinning. And we like an example where we say, for example, of massive twinning that when we have the twinning of the car traffic in a city that allows to take intelligent decisions for the traffic light regulation as a function of many parameters. And this specific example, specific use case requires massive amount of data and processing at the edge that go beyond 5G capabilities. And also this means a step change in terms of performance. And that's why we say that 6G brings to 5G a scaling perspective in terms of performance, data, speed, real time, and with new technology enablers like AI and blockchain. And last but not least, sustainability is at the top of our European agenda. It is a critical issue addressed in almost all 6G initiatives. And against this background, we see a lot of open opportunities to shape the future 6G landscape. Especially from a standardization perspective, as mentioned before, it is expected that 6G standardization study work will start around 2025, which gives us a significant window of opportunity. It gives a window of opportunity to Europe to study in detail the multiple technologies and to realize future 6G systems. And Europe can and should be the leader in this area. I'm sure you have seen this slide before, so I'm not going to go into the details, but I would like to, this comes from the 5G vision that was published in 2021 on the core 6G, core technological areas of 6G. So you can see that they range from system network architecture, edge and ubiquitous computing, but still, I don't know, non-terrestrial communications and devices and components. Of course, you can see also that AI and machine learning is applicable to all technologies. As an example, AI can be employed to optimize, for example, various radio interface functionalities. And there is a big challenge also to use AI from an end-to-end perspective, as we know, because things are currently optimized locally, but the decisions in various parts of the network may be conflicting or contradictory sometimes. So this is another important challenge. Now we can see that something else that I would like to emphasize here is the dependence on electronic technologies, components and devices that are used for 6G research. So this includes the whole range of components and such as processors, memories, antennas, optical components. So this is also another important area of technology for 6G. On the left, we have the list of requirements that drive the design of 6G, some of which are already mentioned. And the key features of 6G will include this intelligent connected management, programmability, determinism, scalability, affordability, accessibility, and so on. So these are the main drivers. And the right column included the envisaged set of KPIs. So 6G needs to stretch, as we say, the KPIs that 5G can achieve now. Some KPIs are identified, but not all defined. And it is important to mention that we don't speak only about speed, latency, reliability here, but there are some KPIs with increased importance for the 6G use cases, like positioning or like energy efficiency, which is not wishful thinking. Now we have to implement it in the context of sustainability and green deal policy, I mean. It is the low cost of technology or other societal KPIs or determinism, which is also a very new important area of 6G research. So I'm going to move to the next one, which is I would like to during the second part of my presentation to give you some results, some insights of our first calls, SNS calls, and what we do in terms of research in Europe. Our first SNS call was indeed structured around the previously mentioned targets and requirements. So SNS phase 1 was built upon the outcomes of 5G PPP projects and designed in a way to capitalize on the results from other instruments or other initiatives like national initiatives or like open run initiatives. So we took into account all these different, let's say, European initiatives. And there were two revolutionary streams, as you can see. Targeted concepts in the area of IoT, cloud IoT environments to support massive device connectivity and ultra-reliable communications, so on top of the usual enhanced mobile broadband services. We also targeted SNS experimental infrastructures from the start to gradually build up these capabilities, and we also tried to include large-scale pilots from the beginning. And this is a big difference from the 5G PPP program, where these two streams, these two areas were introduced later in the program. We also have this holistic system perspective. This was the flagship project, which is supposed to follow up on HexaX project. As a result of this first call, a total of 35 projects. I don't know if I have time. I heard the bell. So we'll see how much time I have. A total of 35 research innovation projects has been selected, currently at grant agreement preparation, and they will all start 1st of January. So we have projects covering a lot of areas that I will show you later. You're all welcome, by the way, to, if not already done, to check our news item by introducing the new projects, the first call. Very quickly, just to summarize, to see exactly the roadmap and where SNS phase 1 is located. So it illustrates the phases of all these 4 streams. And of course, the SNS roadmap is expected to be further updated considering the SNS objectives and the key achievements from phase 1 projects. And it is also, as you can see, it is also envisioned that complementary results from the streams may be used in the subsequent phases of the program, of the roadmap. And I also include an indicative, the 3GPP roadmap here, just again to emphasize on the fact that there is a window of opportunity till around 2025, when the 6G starting specification will start. But of course, 3GPP is not the only SDO, but it's still indicative of the time plan that we need to follow. Very quickly, some figures from the first call. In coordination with the 6GIA office, a portfolio analysis took place during summer, and it showed some interesting results. You can see in terms of coverage, for example, that of the different areas that the projects have identified in terms of coverage. Of course, some topics fit into more than one categories, as you know. An important note here is that the topic coverage is in terms of effort, not showing the actual level of coverage, depending on the area of broadness. For example, a topic identified as covered by project does not necessarily imply full coverage, as different technological approaches may exist. As an example, you see, for example, NPN with 7% in architecture. Even architecture covers 25%. There's still room for different technological approaches, for example, the use of AI. So this is really indicative. Some results are also some key, let's say, takeaways from the portfolio analysis is that we have, in wireless, we have strong focus on terahertz technologies, but there is a small gap in spectrum management, and so we need to see that in the next call. We have a coverage of microelectronics, but still needs to further, let's say, research in the area. There was no coverage of nanothings networking and troposphere networking, and so there were streams that were included in the streams. There's good coverage in optics and NPN on security, so there's still room for different approaches. And there are some scattered sustainability aspects. In terms of vertical, you can see that the main focus was on media, gaming, industrial IoT, and PDR. And some vectors are, vertical sectors are less covered, like the automotive, smart cities, health, agriculture, and education. All in all, we had a lot of unique beneficiaries in our program, almost 20% funding for SMEs, very close to the target. And then an important also percentage of 30% participating in the projects are not the 6GIA members, which shows the openness and inclusiveness of our program. About the next steps, our work program 2023-24 is under preparation. It will be published in December. The second call will open mid-January with a budget of around 130 million euros. The focus of this 6GIA now is to complement on enabling technologies from the call one and leave room, of course, for longer-term R&D on disruptive concepts as well. You will notice that there is no stream A in the next work program, so we think that this is fully covered. And compared to the phase one, just a few points, because that it includes a reinforced focus on key technological topics that are not were not present in call one. We have a reinforced emphasis on sustainability and societal issues. We have a new stream, some set of activities on microelectronics for 6G, following the collaboration with KDP-JU. We have a good set of focused international cooperation activities, targeting US in 2023, Japan and Korea in 24, regions with clear policy agreements and partnerships. We will have also some complementary and extended opportunities in terms of trials and platforms, experimental platforms, where we have some federated view, concept of federation will be included. And we will have new verticals, the ones that were identified as not present in call one, like automotive, health, smart cities, farming, and education. And we will extend the stakeholder base, notably towards microelectronics and more vertical user industries. By way of conclusion, I would like to reiterate the main messages in the presentation. Europe is fully committed to 6G. There is already a lot of running RNI, which capitalizes on 5GBP results. And SNSJU, this new organization, will further amplify this research and will support this research in the next period. Even though there is no globally established vision, we know that there are important new technologies and important societal and sustainability drivers, and the need to have a full supply chains from microelectronics up to services. And in terms of call one, there were very good results, and we have a good basis for future calls. 35 projects will start now in January, and the new work program is under preparation and will be published in December 22. And as mentioned many times during my presentation, we have 2 years ahead of us as window of opportunity to shape the 6G technologies. So now is the time for Europe to shape and lead future 6G research towards standardization activities. And that concludes my presentation. I hope I didn't spend so much time, more time than already planned. Many thanks.
Thank you very much, Pavlos. Very dense presentation. The presentation, I remind the audience, will be made available, so you will have a chance to go back to all information that was provided. Now, with our program, I would pass on to the next slot that is dedicated to several speakers that will bring us their insight. Pavlos, may I ask you to stop sharing your screen? Thank you very much.
What I'm trying, sorry.
No
Stop share.
problems.
Yes,
Great.
Thank you once again.
Great. So, oops, something happened. I don't see anymore myself. I should come again. Here we go. So now I wanted to introduce you the next speaker, that is Hans Schotten, that will present us the German 6G program, the structure and the focus areas. Hans, the floor is yours. Thank you very much.
Yeah, welcome everybody. I hope you can see my slides. And
yes, we can. Perfect.
Okay, great.
And we can hear.
Thanks. Yeah, welcome everybody. My name is Hans Schotten. I have the pleasure to be the coordinator of the German 6G platform, which is a kind of an umbrella organization for the German 6G program that I'm now plan to present. And yeah, thank you very much for the invitation to one6G, and congratulations to this super event with this long list of interesting presentations. I've seen that we already have far more than 200 attendees, so certainly a big success. So congratulations, and thanks again for the invitation. The German 6G program was announced in April 2021. We all know that already several 6G programs started before, and then there was an announcement that also Germany will set up a 6G program. Around 700 million euro were allocated to this, and several instruments were defined, so different kinds of projects that form this overall program. One is the 6G platform that I have the pleasure to coordinate. That is the umbrella organization. Then we have 4 research hubs. We have industry-led projects, 18. The last one will start next week. Then we have all of them being active. We will get a number of projects on resilience of communication infrastructure. I guess it's not difficult to justify this and explain the motivation. That's a geopolitical context, and we have seen in the last month certainly a significant change of the priorities in the 6G design process. And then we also integrate some part of Celtic projects, the German part of Celtic projects. So overall, it will be a program with different kinds of instruments and different kinds of projects. And the platform has a responsibility to somehow provide a networking platform, umbrella organization. In particular, of course, to has a responsibility to manage external liaisons. So we are not isolated. We are part of the European 6G arena. Pavel already mentioned that there are quite some projects in Europe. And of course, we want to work towards one global 6G standard. And we have to guarantee that there is a harmonization of concepts. And that's then the responsibility of the platform to guarantee this. So also to harmonize the different concepts. We have some additional priorities. One is, of course, dealing with startups and SMEs to help them to get into the party, which is non-trivial given that we are talking about a global process and we have many big companies. Then a very specific target motivation that we have that might be different to other countries. So we have seen significant problems with the acceptance of 5G in the past in vertical industries that found that their requirements were included too late in the process, and in the public due to discussions about electromagnetic exposition. And by a bidirectional sized communication process, we try to avoid this from the beginning and work towards this. Another issue that is very specific for the German market, or might be specific, is that we have a lack of skilled worker force. And so we also include qualification processes in order to provide industry with the worker force that they need. And finally, of course, then to harmonize the contributions to the UN SDGs coming out of the German program. And Yeah, with this, a few words. So how's the platform organized? The platform has different working groups, and the first one, and that already indicates how important we feel that this is this working group one on science communication, where we address the already mentioned topics. So talking to the public in order to explain the concept, the ideas, the benefits for society, and also to get feedback on certain issues so that we have in an early phase included the requirements. So privacy, electromagnetic exposition, technology sovereignty, and participation in terms of affordable coverage in rural areas are of course the important topics there. And then of course to guarantee that the vertical industry in an early phase are integrated and their requirements covered. We have more working groups, and there might be more in the future. So one is on sustainability participation. So that's dealing, of course, with reducing greenhouse gas emissions, and so having an energy efficient 6G and guaranteeing that 6G can really meet the requirements as key enabler for society, for a sustainable digitalization. I think digital twinning, many things were already mentioned by Pavlos, of course. So that's very much aligned, and not a big surprise, of course, with the motivation and the objectives of the European program. And we are covering here the contributions from the German program to these overall goals. The second one is maximizing impact. That's where we organize the interaction with the vertical industries. And you can see here that we found that there are certain groups, and some of them were already on Pavlos' slide. So PMSE, PPDR, automation, automotive, of course. And the idea is that within the workshops, and we will then also work with 6GIA and with HexaX, of course, will be done in a joint process so that we can exchange information on the feedbacks that we get on alignment of roadmaps. And then, of course, working towards one common global 6G vision. And the last one, working group 5, the last one that is already active is, of course, on security, resilience, and trustworthiness. And that, I guess, does not need to be explained anymore. The second, so that's the platform. Then the second group of instruments that we have are the research hubs. We have 4 big research hubs. Here is just the place where it's coordinated, and they are indeed comparable large research centers of excellence, so with 160 research groups and 250 million euro budget. So these are significant efforts that provide input to the industry projects. And as mentioned, we have 18. So in the industry projects, we also have academic partners, but they are always led by industry. And we have participation from all those parties that you can expect from German programs. So we have, of course, infrastructure vendors, we have MNOs, we have test and measurement equipment providers. We have a strong link to the microelectronic side, yeah, because we feel that quite some innovations are coming from this side, and quite some requirements can only be met in collaboration with innovations on the microelectronic side. And we also have those that at the end need 6G and might have to implement it in their concepts on board. So OEMs for many domains and infrastructure operators, and of course SMEs. And here are some examples for the use case scenarios. So it's not so strictly split as we have seen this in the last presentation, but we have campus networks. So in particular, of course, automation, but also campus logistics. We have medical scenarios being addressed, hospital, emergency operations theater. We have mobility, any kind of mobility, automotive, commercial vehicles, and we have quite some activities on drones and satellites, and global coverage, rural area coverage in X networking, so networks in networks as a key concept. And on the technology side, joint communication and sensing is a big focus area, real-time and synchronized networking, We have a little bit more probably than in other programs emphasize on D2D and infrastructure less networking. Networking concepts that are independent of infrastructure in emergency cases, but also in mobile cases and in rural areas. Device management, authentication, so everything around security, everything around resilience by design. The topic Open RAN in different variants and from different perspectives. So it's not just an Open RAN evolution, but it's, let's say, looking at this from a much more generic perspective and probably reconsidering quite some of the concepts. So having it end to end, having it more dynamic. So as you can already see, OpenXG is something that goes significantly beyond what is currently discussed as Open RAN. The use of AR and artificial intelligence, it's not a big surprise. And then we have topics that are related, and we have dedicated projects for realizing innovations on the microelectronic side, in particular, RF microelectronic that is required for the 6G program. And at the end, some examples for the project. So there is one project that you might already have heard about because it started some months ago at 6G ANA, led by Nokia, which is the German 6G flagship project that has the responsibility to provide an integrated system engineering approach to 6G and integrate some of the concepts in one project in very tight collaboration with the platform. So there will be a working group in the platform that is then coordinated in collaboration with 6G ANA so that all projects can contribute to this process. Then we have 6G takeoff led by Deutsche Telekom that is dealing with 3D networking, so deeply integrated 6G non-terrestrial networks. So not just a separate satellite communication network, but an integrated one. Also hubs, drones being integrated, but integrated in the terrestrial 6G networks. 6G Campus led by NXP is focusing on this already mentioned OpenXG approach, which is a more generic version or alternative view on the disaggregation concept, including device management, authentication, and in particular, opening interfaces for external AI usage and joint communication and sensing with a very strong focus on campus networks. Health is a topic, I think, not a big surprise. Smart hospitals, remote patient monitoring, where technologies are required as sensing, privacy, resilience. We have, and these are it's the last slide. So 6G Next is an example for a project where we are integrating the application view with a high-speed software layer directly in the network. ECAS for mobility is dealing with integrating different mobility scenarios. And then we also have projects that really work on simplifying the usage, so addressing the problem, how can we increase the acceptance of the non-public network concept in vertical industries, for example, by having out-of-the-box campus network solutions, secure zero-touch operation, and these kind of concepts that might help to increase the acceptance that is currently, let's say, in the 5G arena, could be improved. Okay, thank you very much. So I hope that provides the first overview. So as said, we are very much committed to contributing with the 6G program to a global 6G process, and in particular, of course, to the European process. And we are happy to collaborate with everybody being interested. So feel free to contact me. Thank you very much.
Thank you very much, Hans. Again, a lot of information, very, very insightful presentation. The presentation will be made available. I don't see a lot of questions. I don't know if our audience is still a little bit sleepy or if the presentations are so clear, but definitely if you have any other point you would like to touch, please drop questions in our chat. Okay, so now it's time to introduce Mrs. Feifei Lou from the NGMN that will talk about the journey to 6G from the NGMN perspective. Feifei, the floor goes to you. Many thanks.
Thank you, Monique.
We see your screen perfectly and we can hear.
Yeah, thank you. Good morning, everyone, and thanks for inviting us to this great event. I'm very happy to see that we have already more than 20 participants joining today. Apologies first that our CEO, Anita Dola, couldn't make to this event, and I'm presenting. My name is Feifei Lou. I'm the Executive Program Manager in NGMN. I'm managing our 6G program. So today I will introduce you to our 6G projects, what we are doing here in NGMN. For those of you who don't know NGMN well, we are an operator-driven alliance. Our membership includes leading operators, vendors, software companies, consulting companies, as well as the research institutes and universities. Right now, we have more than 80 companies in our membership, and we are still growing. So our membership representing the entire value chain. In 2021, our board decided our strategic focus topics, which is to address the industry's main challenges nowadays and also in the next few years, while we are still supporting the 5G's full potential through our 5G projects. Our three main focus areas are the mastering the route to disaggregation with a focus on the end-to-end operating model, green future networks, and 6G. And all these three topics are equally important and interconnect and build upon each other. And obviously for today's presentation, I will focus on 6G. So NGMN has a track record in substantially providing industry guidance on 4G and 5G development and is well positioned to provide the relevant and timely guidance to the whole ecosystem. Starting from 2019, there has been a significant discussions on 6G in the industry and also academia. So we however, there are very few opinions coming from operators. So in order to provide early and timely direction to the ecosystem and to the industry, we launched the 6G project in October 2020, which is a new milestone for NGMN. We are very excited to be working on this future vision project and set the footprint for the generations to come. Our goal as NGMN is to remain at the forefront of next generation mobile networks. As a global organization representing the entire value chain, NGMN is set to provide impactful guidance for the global 6G activities and to respond to the needs for the end users, societies, global operators, and the ecosystem as a whole. It is therefore essential that we started anticipating the future societal needs and elaborate the drivers for the mobile communications in the future. So our 6G project published our first deliverable focusing on the 6 drivers and vision from operators' point of view in April 2021. And then we published the 6 use cases and analysis early this year. And we also delivered input to the next stage of the ITUR process, and the greater details, specifics, and identification of the 6G technology components for further study will be developed in the years to come. In the 6G drivers and the vision white paper, NGMN operators identified the key drivers for 6G and outlined our vision for 6G. And also we outlined the key challenges to be considered in the journey to 6G. We emphasize the need for a healthy and unified global ecosystem and standards. I'm happy to hear from the previous speaker. They also highlight the importance of the global unified standard. So we identify 3 drivers, and the first one is the societal goals. Future technologies should contribute further to the success of a number of UN SDG goals. And secondly is the market expectations. Customer requirements need to be satisfied by offering new services and capabilities supported by evolving technologies and in a cost-effective manner. Third one is the operational necessities. There is a strong need to make the planning, deployment, operation, management, and performance of the mobile operators network more efficient. So we strongly believe that the societal and operational requirements need to be considered in the development of the next generation, and operators are in a unique position to engage with the end users. Our board strongly recommend that these drivers should be prioritized in the global research and development of the next generation standards and technologies. We identify some fundamental aspects which need to be considered before starting the development of the next generation technology. So I would like to highlight just one point here, that's the need for unity and integrity of global standards. Over the years, the standards development landscape has changed significantly. Rightfully, many new organizations are risen to address the shortcomings of the existing standards. But in addition, the new geopolitical realities are under development, and which propose a potential challenge to the overall unity of the standards development paradigm. Therefore, it's vitally important to prevent standards duplication, which causes market delays and confusion, as well as the standards divergence, which could lead to fragmentation. The purpose of the use cases work is to identify the use cases grouping that have the greatest opportunities, have the greatest values. So in this work, we try to predict the major trends for the time frame 2030 and beyond. And we also through our discussions and deliverables, we would like to guide, give the ecosystem the guidance and the requirements, and also to motivate more innovations and new capabilities. The use case groupings, we first do the technology enablers that should be required, and the level of the differentiation it would offer relative to 5G. That's what we has been described in this white paper, and a common and foundational requirement for 6G use cases is they must have a route towards creating the value that justify the need for new technology development and the significant cost it may incur. And the 6G drivers and vision white paper provides a framework that identify the important drivers from which the use case can be assessed against. So a differentiated technology evolution is also required. Any new technology development should be assessed with respect to its differentiation from fully featured 5G as defined with 2020, and any improvements should be benchmarked, including pragmatic deployment scenarios with the law of diminishing returns in mind. So our team started from the collection of use cases from our partners. So in total, about 50 use cases covering very broad and various scenarios. Then the proposed use cases are classified into broader categories of use case families. And based on the common key characteristics of the applications, the team grouped and developed 14 generic use cases for further analysis. So this is the our use cases, families and the generic use cases. First one is the enhanced human communication, which includes some very immersive applications. And second is the enhanced machine communication, including robots and interaction between robots and human or cobots. The third one is enabling services, which includes some new applications, which don't exactly fall into the previous two categories. And the fourth one is the network evolution, that operators would like to see the enhancement of their network. For example, the application of native AI or AI as a service, and the enhancement of coverage. And nowadays, a very important topic is the energy efficiency of the network. Our team, the objective of this use case analysis is to understand the viability and market opportunity, and to provide the guidance on the 6G design and the requirements. We mainly look at applicability, deliverability, and its differentiation relative to 5G. And we currently have more than 50 companies in our project, including operators, vendors, as well as the academia. So this is a great mix of the industry and academia. And our partners are working on the 6G requirements right now. So you are very welcome to join our 6G project. So this shows our other publications in other areas. They are all available on our website. Please feel free to take a look. And thank you very much. And you're very welcome to join us. Thanks for inviting us.
Thanks a lot, Feifei. I will remind the audience that the presentation will be made available. So definitely you will have a chance to look in more details at the many activities of the organization that Feifei presented and represents. So our discovery journey goes on, and after the NGMN, it will be now the turn to discover ETSI, the ETSI context, organization, and activities of relevance to the one6G scope with David Boswarthick. David, I would leave you the floor. I don't see your face. I hope you're with us. You were with us earlier on. David? Yes, great.
Hello.
Perfect. We see you and we see your screen and we can hear your voice.
Perfect.
The floor is yours.
We have all three things are working, which is great. Good morning, everybody. Good morning, afternoon, depending on the time zone. My name is David Boswarthick. I'm the ETSI Director of New Technologies. Today, I am going to present the ETSI approach to research, innovation, and technology trends, including, but not only limited to 6G. For those of you who don't know ETSI, hopefully everybody would know of ETSI. We are an independent non-for-profit standards organization based in the south of France. We are about 30 years young or old, and we are founding partners of both 3GPP, where most of the generations of mobile networks have been defined, and 1M2M, looking at M2M and IoT technologies. We currently have about 908 members from over 63 countries, over 5 continents. So although we're a European standards organization, we're obviously very impactful on the global scene as well. One important element of note is that all of our specifications and standards are available free of charge from that website. So if you're interested in any of the work we do, you can always get the latest deliverables downloaded for free. one thing I wanted to look at in this presentation is the role of research and innovation, because when you think about standardization, you may not automatically think of research and innovation. In ETSI, we have about 14% of our 908 members who come from research, public and private, or academia, so universities. So this is about 14% of our members who are actually actively working in research, innovation, and education of the telecoms engineers of tomorrow. So this really means that we encourage a constant flow of research and innovation work into our standards work, and we do this in three ways. One, we have a dedicated group, which is called ETSI Rise or ETSI Board Rise, which is where we look at building all the enablers, all the links out towards research projects, research platforms, and also universities. We work with European platforms such as Horizon Europe, the SNSJU, as we heard earlier on, 5G PPP, 6G IA now, of course, and Network Europe. We work with individual projects, so you can imagine HexaX. We work with other flagship projects such as 6G flagship in Finland, and also we coordinate and cooperate with NextG Alliance in the US, one6G, which is why we're here today, and even projects such as IOWN in Japan, looking more at the optical and the fiber side. We also reach out to our significant number of university members, and we help them with innovation, research, and education of their students as well. So that's one element. Second element is technology mapping. So you can't really define standards if you don't know where we're going. And we will have heard in today's presentations, what could 6 be, what technologies could be inside. And it's very important for ETSI to be able to track these. So to this end, we've created something called the ETR, ETSI Technology Radar, and that looks at tracking the coming technology trends in the next series of years, and I'll get onto that in another slide. And then finally, we have a team in ETSI called ETSI Net, which is basically me, and we're responsible for building the tools, making the enablers, reaching out to the universities, reaching out to the projects, tracking the technology. And then when all of that comes together, when the time is right, we work with our members, present and future, to create new working groups and new ISGs and new technical bodies in ETSI. And I'll come back to that briefly at the end of the presentation. So back to the technology radar. Well, this is published as a white paper. It came out in April 2021. It's about 45, 47 pages, so it's not too difficult to read. And the intent was really to identify what are the main technology trends happening today and what will be on the radar for the next 5 to 7 years. So what will be hitting our ICT networks in the coming decade, let's say. Once you get beyond 7 years, it's really hard to say these will be the technologies which are happening in 6G, beyond 6G, 7G, but we can have a pretty good idea. The ETI included 10 major trends, wide trends. They're not very deep trends. One is obviously evolution of mobile networks, so from moving from 3G to 4G to 5G, 5G advanced, 6G, and then all the way up to 12G in a few decades' time. Also, the role of artificial intelligence, which we've seen as evolving. Today, we have it in network management, we have it in applications. In 6G, we'll probably have some level of native autonomous AI. This links into the other technology area, which is described in the ETR, which is autonomous networks. This is obviously very important to the telecom operators and vendors. This is how to get their networks zero touch, self-organizing, self-healing, and self-synthesizing network, which basically runs itself and dimensions itself using AI to a certain extent. The very horizontal topic of cybersecurity, including security, trust, privacy, and also encompassing AI. How can AI be used to secure networks, and how can networks be made secure against AI attack? Again, on security, we have a technology domain looking at blockchain, permission distributed ledgers, and eventually NFTs. This is another developing area. The area of big data, which we've called dynamic data. How is data shared? What it is in naming and its semantic? How do we do semantic interoperability? How do we do data analytics and processing? So this is captured in a chapter called Dynamic Data. The evolution of augmented reality, virtual reality into mixed reality, which takes us down the road of digital twins and meta, or the various metaverses. The evolution of machine-to-machine IoT, moving on to the Internet of Skills, the Internet of Senses, the Internet of Everything. So this is obviously a very big domain, which is evolving very quickly these days. And then the specific technology area of quantum, be it quantum key distribution, which is used for identification and security, and also quantum safe cryptography, which is looking at securing networks against attack from quantum compute. So this is a very interesting area where a lot of cutting edge research is happening, and this will evolve to include such things as quantum clocking, quantum sensing, and also a longer evolution towards something called the quantum internet. Autonomous systems we've classified as robots, cobots, drones, HAPSs, unmanned systems, including autonomous networks. So these are really how do we manage autonomous systems. So that was the first edition of the radar. If we look at the second edition of the radar, which is currently under review, we're hoping this will be published in April 2023. So there's still time for people to put in contribution and comment on what could be the most important technology for the next coming 5 to 7 years. Currently, we've identified 11 additional trends. So in addition to the initial 10 trends, taking it up to 21, including such areas as photonics, the evolution of millimeter wave up to terahertz, sub-terahertz, terahertz, the role of reflective or reconfigurable intelligent surfaces, the role of optical wireless communications, including visible light, Li-Fi, LiDAR, and other such technologies, the integration or the evolution of satellites to include LEO, MEO, GEO orbits, high throughput satellites, the smaller CubeSats, high altitude platforms, and even UAVs. So this tropospheric and space communications, how that will be integrated into the future communication network. The evolution of edge and distributed computing, so moving from cloud to edge, to far edge, to distributed edge, and how that will be managed. A new area which is interesting, especially for 6G, is the integration of communication and sensing. So when a network can actually communicate and sense, and you'll see this is being raised out in several 6G white papers and vision papers. And then with the evolution of computing, so with classical computing, neuromorphic computing, quantum computing, how that computing power, including energy efficiency, will be integrated into the compute and communicate fabric. So we have this whole merge of fabrics between computing, networking, and communication. This leads us on to the very important topic of sustainability, which is not only about CO2 and not only about energy, it's about sustainability of many things, which you will have heard from the NGMN just before my presentation. And then also, what is the next device we'll be using? Is it a phone? Is it a car? Is it a drone that's connected? Is it smart glasses? Is it an implant in the back of the brain? What will the next device be that we will need to connect to and manage? And this we've defined in the ETR as the next generation of user interfaces, which includes devices. And then we have an additional one, which is self-organizing wireless networks, so cognitive radio, efficient radio spectrum. So again, this takes us back to sustainability. How can we efficiently manage the limited resources here at Spectrum by using reconfigurable cognitive radio technologies? So that's the technology radar. This has obviously led us to do a lot of thinking and reading about what could 6G be. We're at the stage where everybody is announcing their 6G vision, their 6G roadmap. I think most standards organization and for most vendors, most operators have some sort of white paper vision for 6G. It's very important to say that we're only at the vision stage and the research stage, but it's very important in events like this that we actually share our visions and share our research plans and share our standardization roadmaps as well, so we can move towards convergence as opposed to divergence. We're not expecting to see the first 6G services before 2030, but we've seen this with 5G as well. We can have an early drop, we can have a push for people trying to get 6G out for some sporting event or some global event. So we have to be careful, not releasing 6G too early. For today, the agreed timeline is around 2030 for initial simple 6G services. But again, we don't really know what 6G will be. We're sharing the roadmaps, we're sharing the visions. We're not expecting initial 6G work items to turn up in 3GPP until about 2026, around release 20 for the studies and release 21 for the first specifications. So we're still in a stage where we're defining 5G evolution, release 18. We're looking at the arrival of 6G, but these will run as parallel tracks. We will have at least 10 years of 5G evolved ahead of us, more than 10 years. and we'll have years, 10 years and beyond for 6G. So these will evolve as parallel networks and parallel tracks. In ETSI, we really only speak about 6G research and pre-standardization work, as we don't want to push 6G too early from full standardization. We'll leave this up to 3GPP. Looking at the white papers, we've come across several common indicators. These are technologies which everybody's saying this is important, this may be, or this will be in 6G. So obviously you have the millimeter wave sub-terahertz, full terahertz evolution. You have the integration of AI into a more AI defined for the network, native AI. You have the use of RIS, reconfigurable intelligent surfaces, to save energy and also increase the range of coverage. The full integration of non-terrestrial networks, the arrival of integrated sensing and communicating networks, the big focus on sustainability and energy efficiency, and then the evolution of radio technologies such as full duplex, distributed massive MIMO, and others. So these are just common factors that people are stating in their white papers may be technologies for 6G, and we'll probably hear some more of those later in presentations today. What it's important to say is that ETSI seeks to promote a single standard for 6G, one standard. We're aware that with geopolitics and even standards evolution, there is some risk of fragmentation. So we're proactively working with all of our partners to avoid the risk of standards multiplication, so more and more standards, ossification, so standards no longer being able to do what they're supposed to do, and then fragmentation, that we have multiple standards for one system. So that's very important that we all work together on this. A few of the recent activities, which we could say relate to 6G, we recently, September of last year, created a new ISG industry specification group on RIS, reconfigurable intelligent services. This has been running for just over a year. We currently have 35 member companies. We have 2 non-ETSI member companies, so it's important to show that we're opening up to ETSI non-members as well to get their opinions either from research categories or from other international categories. And they're currently working on 3 deliverables which will define how RIS could work and could be integrated into a future 6G network. And you can find more details on the websites down at the bottom. Something which is very fresh is the creation of a brand new ISG, which is ISG on terahertz modeling. And this was approved in September of this year. Interesting to note, we had 25 ETSI members supporting the approval of this ISG, which is a record level. Normally it's about 5 or 7 companies. So this proves the interest, the hype, the concern around terahertz potentially for 6G. So it's interesting to note that there is a lot of support on this group, and we expect to see the kickoff meeting happening on the 8th of December. So it's coming very soon. Obviously, these are 2 pre-standards groups which have happened. What we're doing now is looking at what other pre-standardization activities may need to happen. We do this by looking at the ETSI technology radar, the ETR, which is a starting point, either the first 10 areas or the additional 11 areas. They'll tell us where we may need standardization in the next 6 months, 12 months, 2 years. But as ETSI is a fully 100% member-driven organization, we have to wait for our members to bring this work to us. We can discuss with them about the standardization plans, their technology plans, but we really do need for them to bring the work to ETSI, and then we can develop it when the time is right. For the moment, there's really no consensus on what 6G technologies shall be or will be, but it's certain that it'll be a mix of an evolution, so evolving 5G advanced into something better, faster, lower latency, greater coverage, and then possibly some revolutionary technology leaps or even architectural changes, which will require a new generation, something that means it cannot be done in 5G advanced. As I mentioned earlier, early estimate of what could be inside 6G, terahertz, RIS, integrated sense and communication, greater focus on trust, privacy, security, and particularly sustainability, and many, many others which will be defined over the coming months and years. Just wanted to mention this is brand new. We have an ETSI research conference, which we would be ecstatic that one6G members would come to. The interesting element, so it happens in February next year, but the interesting element is we've just had confirmation that 26 of the SNSJU phase 1 projects will be present at the workshop and actually do their launch. So we're hoping to have over 26 projects launching, presenting, doing posters. So if you want to find out about the first phase, the first call of SNSJU, then come to the ETSI workshop next June and have a good talk. So hopefully I haven't overrun. Thank you for your attention.
Thank you very much. There's a couple of questions before we go to the next speaker. Actually, one question from Jesus Alonso Zarate from I2CAT says, very nice and interesting presentation. Do you have the impression that the community has in building a 6G building a vision of 6G based on the technologies that we are developing? Do you share this technology push impression? Do you think is the best way to go? So essentially, are the technologies shaping the 6G vision, or it's the market, the society needs that are pulling for this vision to be drawn the way it's drawn?
No, very, very good question, and a very good point that I think everybody should consider. We can traditionally say we have a technology, what are we going to use it for? And I think that's probably the wrong way around. We need to say what needs to be done in 6G. So what do we wish to achieve? And this is why we're seeing more focus on societal impact, sustainability, reducing the digital divide, ensuring the interconnectivity of many things. So these are not technical requirements, they're more sort of user requirements or use cases. So I think it's great to have technology. Technology is often done in research, and we need to have really cutting edge research, but we need to understand what 6G is going to have to do. And this is less technology and more use case. So as always, start with the usage, come on to the requirements, do the technology, and then standardize it.
Thank you, David. Then there is another question, always to you, from Joseph. Is the service robot counted as a device?
Is the service robot?
Is a service robot counted as device?
Not in my area of speciality, but I assume if it's connected to the network and it has some autonomy, so it has AI inside and it has some management from the network, then yes, it's a device. And then the interface to that device will be defined over the various UEs. But yeah, depending on the intelligence of the bot and the connection and the control from the network, I would say yes.
Thank you, David. And another question that is about the technology radar. Basically, the question is, does the technology radar justify if a use case can be done by 5G or whether it requires 6G? Meaning, is there a clear distinction between 5G advanced and 6G when they perform the technology investigation?
No, but it would be a fantastic idea to do that. A lot of discussion in industry today is, couldn't we just do this with 5G advanced? Which is why in one of my slides I said you need, it's a general discussion, but you need a generation breaker, something that breaks 5G, that you need to have a 6G. So in the ETSI technology radar, we don't look at the generation specifically because it doesn't all relate to mobile technologies, but we do look at the use requirement. And the thing I didn't mention about the technology radar in ETSI is that it actually looks at the technology, looks at the use cases, and then looks at, is ETSI available or capable of standardizing it? So that's the important thing. It really is the ETSI technology radar. So it's of a more specific level than, let's say, the ITU document.
And then we have another question that is about whether or not there is any efforts from ETSI to standardize risk technology. If you can provide any reference, any detail.
RIS, yep. Well,
RIS, yes.
Yeah, as mentioned in the third slide before the end, there is an ETSI industry specification group called ISG RIS, which has been in place for a year, and they are doing the pre-standards work for RIS or IRS, depends how you want to call it. With a name.
What's the name? Just that we repeat that.
ISG, Industry Specification Group, RIS, Reconfigurable Intelligent Surfaces. And the link is in the presentation.
Is in the third. Okay, great. Great, amazing. Then lots of compliments to the presentations. Yep. I'm happy not only to the one of David, but also from the others. Fascinating how the data rate demand from these technologies will meet the existing processors. Sorry. So, or there will be new, I don't want to use the bad words, or there will be new processors able to follow up on this data rate demand?
Yeah, again, not my area of speciality, but for sure we're going to need so we have an evolution in computing, we have an evolution in computing architectures. We need the corresponding evolution in processing technology, wafer length, width and everything. So as technology becomes more demanding, we're going to need more evolved processors, and also we're putting this focus on processing power and energy efficiency as well, which comes into the architecture of the processor of the chipboard. So yes, all of this needs to evolve together, but not my area of speciality.
Sure, thank you. Anyway, you gave a lot of insight and pointers, so I'm sure that our audience can dig more into the details of what ETSI is doing in this context by checking in more details to the groups or various documents. Now, we can, thank you, David.
Thank you.
The next presentation should have been by someone that cannot be with us. So we now pass to Nigel Jefferies from the Wireless Board Research Forum, and that will give an insight on their activity, on the vision that the WWRF has on next generation mobile networks. Jeffrey, I would give you the floor.
Thank you very much, Monique, and I hope you can all hear me okay. My name's Nigel Jefferies. I'm the chairman of the Wireless World Research Forum. I'll just share my screen with you, and then hopefully we will be able to make a start.
Great. Now we see your slides. Perfect.
Great. Okay, that's fantastic. Okay, I'm going to talk on the subject of building the vision for the next generation mobile network. I'm coming straight from our 48th meeting, which was held in Abu Dhabi, Monday to Wednesday this week. So we had some great discussions there on what the vision is for 6G and what some of the challenges are towards building it. The Wireless World Research Forum, it's an organization where the global wireless community can meet to explore and develop research challenges and those that confront us as we look out beyond the current 5G developments. We were founded back in 2001 through an EU-funded research landscaping project that came to the conclusion that what was needed was an organization a permanent organization, globally based, to look ahead and identify what the research challenges coming up are towards the next generation, whatever that next generation might be. We're based in Switzerland and we're independent, owned by our members. We work towards developing visions of the wireless future, and we currently have around 60 members across 4 continents. We work through a number of working groups. We have a number of core working groups working on things like user needs and requirements, and then communication architectures and technologies, and then very much focusing on the radio side, radio communications architectures. Then we have working groups looking at specific technologies, currently including cybersecurity, 6G vision technologies, high frequency communications, obviously looking at the terahertz scene. And then we've had a special working group working on the IMT 2020 evaluation process for ITU, which is obviously a 5G activity. And then we have a number of what we call vertical integrated platforms, which look at the specific vertical industries. And one of those is dedicated to developing future business models, looking towards how the various players are going to interact and make money in a 6G environment. And then we have VIPs looking at specific industries such as connected vehicles, track-to-train communications for the rail industry, and then e-health, m-health, and wearables looking at the health industry. Our outputs are clustered around our WWRF Outlook series, which is our series of white papers. our library series, which is the proceedings of the meetings we have, and then our book series. We have a number of book publications through our book publishers, River, and we publish in that series. Latest one is on cybersecurity for developing countries, and that's just out now. Our vision of 2030, we've been working on for 4 or 5 years now. I think we were one of the first organizations to actually publish a document looking at what 6G might look like. That was about 5 years ago. Since then, we've been developing some of those concepts, contributing to other organizations' work on the vision, and trying to come up with some of the key drivers and key potential technologies that might play a part. I think we very much like the proposal by Huawei that talked about us entering a hyper-connected, intelligent world where there's a hugely important role to be played in terms of sensing things, in terms of connecting things, and in terms of analyzing and processing things, and that we can bring those together in a 6G network. But what's lacking in that, and I think this was alluded to in the previous presentation when people talked about, is it all about pushing technology, is where do people happen in this architecture in terms of their desires and needs, and what they're expecting from a 6G network. And I think that's where we need to have a little more focus for the time being. Our vision has been an activity of ours for the past couple of years. Our objective is to identify what the key challenges are for enabling the rapid adoption of wireless communication, and to develop stronger collaborations with other leading organizations in both developed and developing economies. Our prime driver in this activity, which we think has been not given sufficient importance so far, is to really use 6G as an opportunity to connect the unconnected or the underconnected at a reasonable cost and with reasonable level of sustainability. So that means we need to identify the key issues and challenges affecting the rapid adoption of wireless communication, particularly in rural and remote communities, as well as identifying the business issues, regulatory issues, environmental issues, and technical issues that affect society. We want to make sure that people identify and prioritize what the requirements are on architecture services and wireless technologies, and develop sustainable business models that are not currently being met by the existing solutions being offered or that are under development in the global market. Because we see wireless connectivity as driving major societal changes, as it has in the past, from 1G, 2G, 3G, 4G, and so on, into what was partly promised with 5G, and hopefully will come to fruition in 6G, where we will have a larger number of well-connected objects that will need to communicate efficiently and effectively with each other. And we see the applications for this exploding as new business models and value chains emerge in different market sectors. And we're already seeing this with the success of 5G private networks in industry, for instance, and this is going to develop much further as we move towards 6G. So we need to enable vertical specific service providers to exist, to complement the mobile network operators' offerings, and provide suitable technical solutions for these different verticals. alongside the development of the 6G vision, we want to bear in mind the United Nations Sustainable Development Goals, which are well known, and I think everybody accepts that these are a valuable thing to work towards. Of course, the targets for these are mostly set around 2030, which is obviously the date of launch of 6G, expected launch of 6G. So may not have a direct impact on the formal achievement of those goals. But I'm sure that these these goals, or an evolution from them, will be there in the 6G era, and we should make sure we design 6G to assist in the achievement of them. So to achieve this level of global inclusion that we're talking about, we're going to need to develop a number of different technologies, and we've heard those alluded to already in previous talks. I think one thing I wanted to emphasize here is that we see a greater role being played by non-terrestrial networks in providing the coverage and flexibility to achieve the connection of everybody who needs to be connected. And those networks will need to be better interworked or integrated, whatever word you want to use, with the existing terrestrial networks as we go forward. And there are lots of options there, and we need to explore those and work out how sustainable, efficient, cost-effective they can be, as well as in terms of whether they can achieve the performance requirements of the 6G network. The key principles that we see for Vision 2030, well, we see important technologies being developed in the realm of spectrally efficient transmission techniques, for instance, in terms of developing new information theory concepts in wireless communications, carrying out propagation and channel modeling for wideband transmission in millimeter bands and terahertz, developing advanced signal processing and versatile air interface design, and developing security and privacy techniques such as emerging ones such as physical layer security, which has potential to be used in 6G networks. And these are areas where WWRF members are carrying out research, publishing results, and bringing together those technologies to see how we can achieve those 6G performance requirements. We see challenging sustainability requirements that need to be focused on. For instance, we need to reduce energy consumption, despite trying to achieve challenging performance requirements with 6G. But how can we do that? I mean, obviously it helps if we can somehow convert energy consumption targets into monetary challenges, such as the way it's done with carbon markets, to balance sustainability and affordability, which are slightly different targets, but and to some extent complementary. And whether we can really set challenges to achieve net zero for the network itself. Techniques that we might attempt include, obviously, increased network sharing. We look at opportunities through the softwareization and virtualization of networks. Of course, that is great in theory, but of course ends up not necessarily being more efficient than the old way of doing things. We need to do more to avoid duplication in the network and end the generational cycle, which in itself is not a sustainable way of doing things. So the challenge might be to say, could we make 6G the last hardware generation and then rely on software upgrades to enable future enhancements? All in all, we need to increase our longer lasting recyclable and reusable equipment and reduce the reliance on scarce commodities. So we see a challenge for regulators and global organizations to set challenging targets that we need to conform to support better analysis of how we measure the economic and social costs and benefits of technology. And very interested in the work being carried out by organizations like DESC on that, on how you model these costs in a realistic way. Obviously, we want to support a new generation of SDGs for the whole world, and ensure that consumers are given back control in a number of areas. And we want to enhance the profile of developing regions to set the priorities here in all these areas of education, health provision, farming, industry, and so on. We think that the ubiquitous coverage will be a critical performance objective. And obviously, everything we do needs to consider real world problems. We want to bring value to people in a human-friendly way, while reviewing the added value for different stakeholders with due consideration for cost efficiency and other aspects. We see a lot of benefit in the network of networks system concept, allowing the existence of tens of thousands of networks in the same geographic area, including even individual cell networks. Private networks with heterogeneous radio access technologies can play a catalytic role in the definition and technology specification of those future radio interfaces. But we don't see a one-size-fits-all radio solution. And we need to carefully identify the use cases and usage scenarios and their specifications. And that's going to play a more important role than ever in identifying what the radio solution should be. There's a huge diversity of real-world problems that we need to deal with. This network of networks concept can be implemented by facilitating, by making use of some of these technology advances. So everybody has a picture of 6G or IMT 2030, as the ITU call it at the moment. This was our attempt. So we have the traditional 5G triangle in the middle still. But then look at the pushing that in three different directions of global connectivity and inclusion, of immersive connectivity, increasing use of intelligence to create intelligent connectivity, and developing a true internet of senses. But we see an important role to be played by short range connectivity. We really need to provide increasingly super efficient short range radio to meet a number of the use cases that we see being available, and that entails or makes use of the availability of a spectrum at higher frequencies, and studies on the developing the capabilities of these frequencies is a very high priority for us. Obviously, and this justifies that, of course, higher frequencies don't propagate through walls, so this means that future base stations will need to be installed indoors. In that case, do we need a new business model for the way in which that happens? New value chains and business models need to be developed there. And obviously, we need to look at spectrum regulation and how we adapt that to this kind of scenario. And generally, we see more variety in network deployment. I think that's fair to say. And I think this is a process that's already happening, and we'll see that increasingly happen as we get moved towards 6G. So in terms of our work on the vision, we are elaborating scenarios and developing them alongside the development of the IMT 2030 vision in ITU. And we're very much supporting the development of scenarios related to these areas that I already mentioned, the global connectivity, immersive and intelligent connectivity, and the Internet of Senses. And there are key performance indicators also being developed, and we're working with ITU to develop these in all those areas. If you want to help us in this work, then I'd like to invite you to our next meeting, which is on at the end of March in Poznan, Poland, hosted by the Poznan University of Technology, and to our world-renowned huddle, which will be taking place in Singapore next year in May. We will be announcing our results there and bringing together the wireless community to identify and tackle the challenges ahead of us. So with that, I'd like to thank you for your attention and ask you whether you have any questions. Thank you very much.
Thank you very much, Nigel. Thanks a lot. I see a couple of questions. To what extent do you think indoors will be tackled by 6G RAT from 3GPP or by an evolved Wi-Fi radio access technology?
Yes, well, simple answer is I don't know. I think there's going to be some competition there to see which technology is most suitable, and I think that competition will be a good thing. But I think there certainly is. There are benefits in having the indoor coverage as part of an integrated cellular system such as 6G, and I think the opportunity is there to integrate those technologies and make that a business success. But it will be a challenge to compete with, as you say, with other technologies that are more directly and currently applied to it.
Absolutely. Thank you, Nigel. Yeah, difficult answers sometimes to give, given there's still a lot of uncertainty how some of these technologies will evolve. There's another question for you. I would take this as the last one before passing to our next speaker. That is, now that we have EVs without electronic vehicles with high capacity electric storage, do you see these fitted with base stations as part of the ground network, something like the Vodafone ODMA proposal for 3G in the late 90s?
Sorry, I missed the beginning of your question. These are...
So you can see it here in the chat. It's the before last question. It says, now that we have EVs high capacity, with high capacity electric storage, do you see this fitted with base stations as part of the ground network? Or like something like the Vodafone ODMA proposal for 3G in the late 90s?
Yes, which I remember well, of course. Yes, I think so. I think the opportunity for mobile ad hoc base stations as part of the network is, yeah, very important. And of course, that will enable us to extend coverage effectively in some of the areas where it needs to be at a reasonable cost. I mean, there are issues about the how you manage this as a business from a business point of view, which we tackled when we were looking at the old Vodafone ODMA proposal as well. But I think this may be the time when that becomes a real opportunity. So yeah, that's an exciting prospect.
Thank you. Thanks a lot, Nigel. So now I will ask to stop sharing your screen before we pass to the next speaker. I would like also to say that Simon Burley, the speaker that we were expecting from Ofcom, cannot be with us because he's stuck in London in the tube because of a strike. So that's why he cannot be with us, unfortunately. Now we will focus more on non-terrestrial networks. And we will have from BMW, but also from the 5G Automotive Association, Olaf Eckart presenting. Olaf, are you there?
Yes, I can hear you.
We can see you, we can hear you. If you want to share, your slides are, I think, coming.
I'm trying to share my screen as well.
Yeah, that's perfect. Perfect. We don't see them as full screen if you want to.
Do you see it now?
No, now we see the background. Or maybe this is your first slide. Can you try
Yes.
to? Okay,
It's
great.
it's the first slide. Yes.
Okay, great. Thank you, Olaf.
Yeah. Yeah. Welcome everybody. My name is Olaf Eckart. I'm representing here BMW. And I just want to give you a perspective how BMW views the role of non-terrestrial networks. We perceive this as very important in the discussion in regards to 6G. And I can fully agree with my previous speaker, with Nigel. He already pointed out that ubiquitous coverage is very important in the upcoming years, because we are much more depending on digital services. In my short speech, I want to talk about the motivation of BMW. Why are we looking to non-terrestrial networks? And we also want to explain what our current perspective on this whole topic is. And we also want to outline some use cases which are important for us, so that you basically get an understanding on how an OEM is viewing this topic. So for the motivation, we have asked ourselves, why should we investigate this topic right now? Why it is so important? And we have identified 5 important drivers for this topic. And the first one is really that we see that the new technology is now arriving. So we see that especially the so-called new space is really disrupting how the whole space industry is working. And we see that a lot of actors are planning to start so-called mega constellations. So we see that thousands of satellites will be in space in the low Earth orbit pretty soon, and this is a huge opportunity also to look to extend the coverage. We also know that there are existing market gaps. Everyone knows that we have a lot of areas where we have limited or no coverage, or where for instance, broadband is not really stable, and therefore we believe that NTN could be a contribution to this topic. We also see that right now the standardization is ongoing for 5G, and this is already preparing the ground on the standardization, which then will continue also for 6G. But right now we just have seen that release 17 has been frozen, where already some measures are integrated for the NTN integration into mobile networks. And the discussion for the release 18 in 5G is really now ongoing. So for us, it's a very good opportunity to get involved and to get the automotive requirements integrated in this discussion. We also see, and that's the fourth driver, we see that it's not as important like how fast our cars are driving, or also design is still an issue or a topic, but digital services are becoming more and more important from the customer's point of view. And these new services, they will have a big contribution on which OEMs will succeed in the long run. So you can imagine online shopping, 4K streaming, AAA gaming, the upcoming metaverse, or autonomous driving. These are all applications which require high coverage, or a very good coverage for data. And therefore, we are pretty much aware that we are very much depending on a good connectivity. And in total, the business models will be disrupted by all these trends. And therefore, I think every OEM should look to this topic and should take it serious. So that's from the motivational point of view. What we also, and this is also like important in order to like manage the expectations towards the non-terrestrial network. We on the positive side, we believe that the NTN can really extend the coverage so that we come closer to a situation where we have ubiquitous connectivity. We also believe that it can contribute to sustain the bandwidth and to what we call seamless connectivity. And we also believe that the network operators have a lot of benefits from that, because we can improve the redundancy. So if the terrestrial networks fail or there is a catastrophe or something like that, then the non-terrestrial network can like play as a redundant layer on this. And then we also believe that the non-terrestrial network can also discharge the terrestrial networks by routing some of the traffic with the broadcast capabilities. So it's for some applications much more efficient to broadcast these the data just instead of taking the terrestrial network. On the other hand, we also believe that we cannot solve all problems, especially the fact that the satellites, they will still have a limited number or a limited bandwidth. If you look on how much data can be handled for a certain area. And the picture on the right-hand side is just trying to illustrate that every satellite will probably have a certain throughput, but this throughput has to be shared by all users which are in the area which is covered by the satellite. So we believe that despite non-terrestrial networks, there will still not an endless capacity available for connectivity. And we also see that the frequency and landing right regulations are very complex, and this is an issue which is still ongoing, especially when you see what's, for instance, happening with the Starlink T-Mobile publications, where they try to use the frequencies of terrestrial mobile providers. And then a lot of discussions we see in the upcoming. So we see a lot of chances, but there are also restrictions. But I also want to point out that we should be aware of these limitations. Looking to the what the benefits are from our point of view, we have like divided the core benefits into two headlines. One is really the ubiquitous connectivity, where we basically believe that certain gaps can be filled, and you can see that that's a picture of the coverage, that not the whole area is covered with terrestrial coverage, and it plays really a role in areas with low settlement density or in any remote location. In cities, we believe that the mobile coverage is already very good, but as soon as you leave these densely populated area, there is the biggest potential for that. There's the other requirement, the seamless connectivity. This is especially important if you look to all kinds of broadband applications, where we want to have uninterrupted connectivity, especially if you drive along highways or on any other road, that we do not want to have interruptions, so that any kind of streaming, for instance, would be made possible. And from these two requirements, we also derive the same requirement as Nigel, also my previous speaker has pointed out. From our point of view, it is very important that these non-terrestrial networks should not be proprietary solutions which are perceived as a standalone solution or a standalone product, but from our point of view, they should be integrated into the mobile networks, and they should be based on the 3GPP standards. So, and therefore we basically want to point out, as soon as this community here is talking about 6G, that the non-terrestrial networks should be also covered by the discussion, because we believe that this is basically an extension of the, so it's not a substitute, like an alternative, but it's rather an extension to the existing networks. So we believe that it is a win-win situation for all players here in the scene. Looking to the the applications we see, we basically distinguish between all kinds of narrowband applications and also some broadband applications. But as you can also see from other publications, for instance, like from the 5G AA, most of the digital services we are talking about, they do not really need a high bandwidth. So a lot of them can also be created with rather low requirements regarding bandwidth and latency. And for instance, a lot of safety services, like what we call remote services, they are already available today. For instance, we have such apps on the mobile phones where we can control or steer the car from remote, can open the doors, lock the doors, and start the heating system and so on. All these applications do not really need a high bandwidth. And there is also a high potential for any kind of maintenance and convenience applications. So that's what we believe, that that the non-terrestrial networks will probably come first with some narrowband services, and later on we can also look to broadband applications. But I personally believe that this will take some longer time, because it's there are still some challenges to provide broadband via satellite to like automotive customers. But as you can see, this is an example from our current 7 series car, where we have integrated a so-called theater screen. So once we are offering 4K streaming to our customers, we should also take care for the necessary connectivity. And gaming is even more challenging, because there we have the challenge of very low latencies, and also video conferencing or metaverse. These are all applications which could be possible in the future if we integrate the non-terrestrial networks. But this is right now basically our perspective on what NTN could contribute, and therefore we are very much interested in getting involved in the discussions on how the non-terrestrial networks can be created in a way that it also fits mobile users. Okay, that's from my side. Thank you very much, and I'm now open for questions.
Thank you very much, Olaf. There was, I'm checking if there are questions. There are no specific questions. for the time being. I invite the speakers to drop the questionnaire. We're slightly late, so I would recommend to drop the questions and to Olaf, and maybe Olaf can take them offline. Now, I would like to remind for who has joined now that our event is being recorded and that the slides will be made available. So thanks a lot again, Olaf. And now I would like to give the floor to our last speaker of this first session, that is Adrian Fischer from BnetzA, and we will focus on the regulating challenges on the way to 6G. Adrian, are you with us?
Yeah, I'm with you. Can you hear me?
Thank you, Adrian. Olaf, yes, Olaf released the screen, so now you should be able to share your screen, Adrian. Yes, not in full.
Should be soon.
Yeah.
So
yes,
I think
perfect.
now it's ready.
The floor is yours.
Thank you. So I'm Adrian Fischer. I'm working for the Federal Network Agency, or Bundesnetzagentur, how it's called in Germany. That's the BnetzA, the short version. Sorry for that. Now for someone who's not a native speaker, that's quite hard. And so I'm the assistant head of section for the international and national spectrum management. And I'm here to talk about the regulative challenges on the way to 6G and the milestones. So the evolution from 5G to 6G will definitely include the connectivity of new applications and networks. And hopefully there will be then, as it was always already planned at 5G, that decentralization of networks. So the edge computing and network of networks with public and private, so that this will be combined, and there will be more bridges between the networks itself. And just like my previous speaker, the inclusion of satellite capacity also is a big plan there, and of course the artificial intelligence in the core. This will then lead hopefully to a higher data rate, improved access, minimal latency, and therefore to a better experience. And but also, of course, all this needs new area of spectrum. And like previous speakers already told, this will be then in the terahertz area above 100 gigahertz. So the timeline of regulation here, you can see the different generations of technology of standards, starting with 3G and now leading up to 6G. And here you can see that 3G started 1985, and then it took several years until the deployment was then made. The red arrow you see there is the most important part for me, at least. It's always when the regulation started. So at first there was the vision and technical standard, and then there was the regulation with the deployment. Now we're trying to get a different time frame, because it's always reasonable to include us in discussions early, so that we also can advise, and you can also then enlighten us, of course, with new technology, new demands, everything that is needed and that is planned, so we can work together to find the best solution possible. And you can see from 3G to 5G that the regulation time always got shorter. So perhaps with 6G we will be more efficient. Let's see, I hope so at least. And so here you can see at the moment we are sharing visions. There is no standardization yet. And so we are in the phase of vision, and I think around the WRC 27 there will be then some plans, and there will be then the first regulative steps that will be then necessary. And so that will be then the part when we will completely be included in this area. So the regulative areas, I think they always start with research, so at the bottom, and then there goes the support to R&D. And there's also one where we can support you, because for the experimental radio service that exists in Germany, and I'm also head of it. So if you got there the need for frequencies for your developments, you can then give me a call or write an email, and I can help you there. Then the next step after technical verification and you see that something works is then the spectrum allocation, if you want, the regulation, the international regulation, of course, because you want to use these frequencies throughout not only Europe, but on the whole world. So in this way, you have to harmonize worldwide. That does the International Telecommunications Unit at the WWRC, and there the radio regulations will be increased. So there will be more regulation, and perhaps there also a change, because at the moment there are several bands that are discussed that could possibly be used, but they are not yet allocated to IMT. So there would then have to be a change. So it's always very reasonable to go to us, and then we can start this conversation on an international level. So you have then the regulation when you want to start. The next step, of course, always is security, one of the most important ones. The more connected we are, I think, the more important is security. And that's why we also have to do there a regulation. So I think that everyone can enjoy their connectivity safely. Then, of course, then the standardization also is done within the BnetzA, that does another section, and they also always appreciate the help and the support from the industry or other ideas or research, everything, of course. And then the standardization is done, and then comes the last point, the efficiency and compatibility. But I don't know if it's really the last point. I think it always goes hand in hand and step everywhere. So it's always important there, because if it doesn't work efficiently, it doesn't make sense to make a standard. So now you can see here the spectrum management itself. The spectrums should be available worldwide. That has to be done via an international frequency allocation. I think the earliest we will speak about 6G frequencies will be the WRC 27, and then WRC 31. I think will also be many discussions about it. And the international harmonization is done via IMT footnotes or IMT recommendations. And then the international worldwide level is set, and then the next level in Europe is, of course, then CEPT and EU decisions. And there also the discussions begin early, of course, because the European countries try to get to one point. And so we are doing WIC preparations there to have the European opinion then on international level. Also the RSPG opinion, of course, and the 6G roadmap is important there. Then it comes to the national level. To have sufficient capacity, in Germany we have technology neutral authorization and licenses. So if there would exist 6G, you could implement it now. So there are no hurdles in Germany that you have to use one standard. If there is a more efficient standard that is just the same secure, you can do that. And at the moment, the frequency allocation for IMT is done via auction. And then so you can get the frequency, you can buy the frequency range that you need if you're an MNO. How it's done in future, we will see. I don't know yet. The challenges, of course, there are many regulative challenges. AI is one of the biggest challenges itself. because artificial intelligence, how to regulate it, we don't know yet. That's why we need input, of course, and we will see then. The regulation, if you go to the middle, you see there 4 points: private, satellite, verticals, MNOs, and they're allocated completely differently. Satellite is done internationally, the other 3 are done nationally. If you go to private, there is a general allowance, so you don't need an individual license. If you go to verticals, for if they don't use RLAN frequencies, you need there an individual license. And if you go to an MNO, they have auctions to get the frequency bands they need. And so then, of course, what we also heard already was the review of radio service definitions that will then include perhaps that 6G will include all these, and perhaps there will be a new definition possible. That's also something we don't know yet, but that's possible, and we then will have to adapt to it. Then the propagation in sub-terahertz, or also terahertz also itself, of course, because in the frequency range, the propagation is completely different. So it will be very challenging to get that done and to do the right licensing for it. And also, of course, for new applications, you need a bigger bandwidth, but there's only exists bigger bandwidth if you go to higher frequencies. If you go to higher frequencies, the frequencies don't travel that long, and there won't be any reflections that you can use there. And that will, furthermore, you need there then more power to transmit the needed bandwidth. And then we come to the point sustainability. I think in today's world, we have to, it's one of the most important things. And if you need more power to get the bandwidth you need, then you, of course, will also need a lot more energy. And with that, the sustainability is one of the most important points here. Then the last point here is new business cases, of course, that have to be included. So I think that wraps it quite up nicely. There are many challenges, not yet many answers, but we are very thankful for contributions there. And if you include us early, I think that's also quite clever for you, because then we can work together, come to a conclusion. So that wraps up everything, and thank you very much.
Thank you very much, Adrian. Thanks a lot. Meanwhile, Simon, that couldn't make it before, made it. So we will catch up now with Simon Burley. If you have questions to Adrian, here it's his email address, and in any case is available to chat with you. So please go ahead. Now, Simon, are you there?
I am.
Great. I will ask you to try to squeeze within 10 minutes, because we used a little bit of time not knowing if you can make it by taking more questions from the audience. So I will give the floor to Simon, and then we will pass to the next session. So Simon, the floor is yours.
Thank you very much.
You can share your screen now with. Great, we see your slides not yet on.
Can you now see my screen?
Now full screen. Yes, please go ahead, Simon.
Okay. Thank you. Well, thank you very much for accommodating the travel challenges that I had this morning. So I'm Simon Burley. I'm a member of the Communications and Media Technology team here in Ofcom. And what I would like to do during this presentation is provide you with some insights as to the work that we're doing as a regulator as we prepare ourselves and embark on the journey towards 6G. So the slides I'm about to take you through really are sort of broken down into sort of 3 areas. First of all, I'll give a very brief overview of who we are, Ofcom as being the UK's independent regulator. And I'll also then take you through some slides to illustrate how we're preparing for 6G and beyond. And then finally, I shall point you to some publications that we've issued on some of the work that we've already done, and also give an indication of the pipeline of what's coming up and in store in terms of future publications. So very briefly, Ofcom, we are the regulatory and competition authority for the broadcasting, telecommunications, and also the postal industries. And we have a statutory duty to represent the interests of citizens and consumers through the promotion of competition and also encouraging investment and innovation in relevant markets. Now, Ofcom comprises a number of groups, and I sit in the technology, data and innovation group. And within that group, there are 4 teams, and I'm going to be taking us through some of the work that we're currently doing in the communications and media technology team. I should highlight that Ofcom really does adopt a tech-first approach to regulation. And so what we're trying to do here is to anticipate rather than react to emerging technologies and technology trends, and understand how they will impact the sectors that we regulate in the future. On an annual basis, we do actually publish sort of our plan of work for the upcoming year, and this can be we consult on this and is published on our website. And you can see that our themes and focus for this current year, is that we want to see investment in strong and secure networks, and also we want to be able, amongst other things, we also want to be able to enable more wireless services in the broader economy. And also as well, you can see that we are taking on the duties of the online safety bill that is currently going through Parliament in terms of enforcing that act, and obviously online safety really is underpinned by all the forms of connectivity that we use on a day-to-day basis, and so the work that we're doing also has, some influence in terms of, what we need to bear in mind from an online safety perspective. So our work in the communications and media technology team really is there to ensure that Ofcom is fit to face the future. And we do this if we take 6G as an area of work that we're currently focusing on. There are a number of themes which I think we're all probably very familiar with in terms of the immersive experiences that we are likely to be encountering and using in the future, and especially with the metaverse as a way of being able to provide those sort of virtual and very enriched and sort of environments in which we can collaborate and communicate with each other, all the way through to the joint comms and sensing and localization sort of use cases that are being sort of that have been identified and are being worked on, and how it can provide that enabler for further development in terms of Industry 4.0, and also improving our ability to live, work and play through smart city and smart life applications. So the work that we do in the team really does take on board a focus on the end user. So we really are putting people and businesses front and center of our work, and we actually want to understand the user needs and the connectivity requirements, and then also the technologies that would be required to deliver them. And this, in a way, then allows us to compare what those user needs are against the technologies that are either currently available or in the process of being standardized, and where we are seeing services or use cases that can't be delivered by either existing technologies or technologies that are currently being developed, then that has a way of then being able to inform us in terms of how we should then shape our horizon scanning work to make sure that we are then continuing to build that that structure so that we have a well-structured, timely and relevant program of work to address. And the way in which we sort of cascade down from those use cases and user needs, we then start to look at things like the connectivity enablers and the spectrum position of how future sort of generations of mobiles are sort of being agreed, and frequencies allocated, etc. And then we also need to understand what are the architectural options and the challenges that operators and network providers will face in terms of being able to delivering some of these new services. And then we want to understand what are the emerging technologies that will underpin the delivery of these services. But of course, as a regulator, it's not just about, and particularly in our team, it's not just about understanding the technology. we also need to understand, how this may then influence and shape our policy and regulatory thinking to make sure that we continue to remain effective in delivering on our duties and serving, the interests of citizens and consumers. So, we really do want to understand, what new use cases and services that will be of high value to people and businesses in the future, and how can technology broaden and deepen the access to these services. And, you can see from this list here, there's a whole range of things that, where we are trying to understand really, how things can lower the barrier to entry for both network providers and also providing more choice to citizens and consumers, all the way through to, the way in which we actually, may want to, set up other regulatory frameworks to accommodate, changes in technology and the security and resilience of service delivery, etc. So, so once we've sort of set out that sort of broad sort of program of work, the next thing that we really need to do on understanding those sort of use cases and services, we need to understand how networks will evolve and also the challenges that network providers will face in terms of, architecting, building and deploying those networks. So there's obviously a lot of transformational change, that has been happening during the course of 5G. So, if we take the traditional mobile architecture on the left-hand side of this chart, we know that, in its basic form, a mobile network comprises, the core network, the radio access network, and then the devices that then basically access those, the network and services via the data network, using those mobile elements. And, traditionally, if we take the RAN, for example, that has traditionally been a model where, a single vendor will provide that equipment to an operator, and it's, it's a very sort of, vertically, monolithically integrated solution. And, there's, it's a one-stop shop in terms of, and you're taking, the best and potentially, the sort of some of the areas that a vendor may not necessarily be quite as good at in terms of, the solutions and the products they're offering, compared to having more choice in an ecosystem where you can actually build a network using elements from multiple vendors, etc. And of course, we are also seeing how networks are now gradually moving towards a service-based architecture, where here a key aspect of that is the separation of control plane and user plane. So this can provide more opportunities to tailor the design and the architecture and the ability to be able to scale a network in line with the network provider's sort of business outcomes and marketing strategy that they want to deliver on. And I've already mentioned, with the RAN, there's this shift from a monolithic to a disaggregated architecture, where that provides opportunities to be able to place, the disaggregated components, at appropriate points in their network, to be able to deal with a wide range of deployment scenarios, from less challenging from a user and a capacity perspective in sort of rural environments, right the way through to very, very high density, high demand environments in sort of large urban conurbations, etc. So it gives operators a lot more freedom and flexibility in terms of how they then scale and build their networks. And of course, all of this is sort of leading us to that path towards 6G and metaverse ready networks, where we envisage, as we move towards 6G, networks would become a lot more converged. We still want to see secure, we believe that obviously they're going to be, naturally we want them to be secure, but there's also going to be high levels of automation. The networks will be more programmable, there'll be more intelligence, and also cloud native. And of course, everybody's there's been mentioned in the presentations before, in some of the earlier presentations. We're also moving towards a world of a network of networks, where the end user won't necessarily know, or actually not really matter that much as to what type of network, or indeed what type of connectivity solution is providing them with that connectivity. They just want to see a ubiquitous, uniform level of service wherever they are. And this sort of gives rise to this notion of anyone, anything, anywhere as the key driver as to how people want to see networks evolve as we go into the future. But of course, this does pose quite a few challenges. You know, as we progress through the various generations, the types of services that people are expecting and wanting to be using, you know, typically require, you know, increases in user data rates, and also the, you know, the latencies for some of these more sort of immersive and gaming type environments that people will be using and continue to use in the future. And of course, you know, as we move towards 6G, there's always ever greater needs to be able to increase, you know, the area capacity, and also be able to deal with greater levels of sort of connection densities as well. So, you know, we need to understand, you know, what are the challenges.
Sorry, we need to converge to the end, because we're already 10 minutes late. So I'm sorry I have to interrupt you, but can you briefly conclude the presentation?
Sure.
Thank you.
So on this next slide, I just want to highlight that, you know, we need to understand a broad range of future use cases, and enabling technologies is actually very, you know, very important and vital for our work. So without going through the details, I think a lot of these topics are probably pretty familiar to everyone, but these are some of the areas that we are currently focusing on as we embark on our journey to preparing ourselves for 6G. You know, we are currently looking at wireless wireline convergence and seeing how that then will progress to a network of networks. We're very much looking at open networking solutions. We believe that that's going to be key for 6G. At the moment, our focus is on 5G, and we're working with a partner called Digital Catapult in the Sonic Labs, which is a very good way for us to understand, you know, how some of these disaggregated and open solutions are progressing. Use cases and services and devices, you could probably appreciate, you know, why we have a very strong interest in understanding that, and sustainability is also a key theme that everyone will no doubt will be talking about during the course of the day. And then there's the enablers such as AI, machine learning, and also MIMO evolution and joint comms and same thing. So a lot of activity, a lot of interesting work that we're doing in the team. And yeah, we are constantly looking to understand what the regulatory implications of some of these new technologies. So very finally, I just want to sort of make a shameless plug that we've already issued quite a number of reports from the work that have come out of the team, and we have a couple more in the pipeline, and there will definitely be more in the future as well. So I really do encourage you to take a look at our website and have a look at some of these publications. And that brings me to the end of my talk, and so thank you very much for listening. And yeah, if anybody has any questions, etc., then please do get in touch, and we'll be more than happy to take you through our work in more detail.
Thank you, Simon. Thank you very much. Apologies for having to step into your presentation, to your words. Again, the slides were very rich, a lot of information.